Hi everyone. In this video clip, I'm going to show you how to solve the Earth as a sphere question. Now, in order for us to solve the Earth as a sphere question, we really must know how to illustrate our Earth and put in all the information given by the question. Now, look at this. We have 4 points in the question. Okay, we have A, B, C, and D. These are 4 points which lie on the surface of the Earth, whereby BD is the diameter of the common parallel of latitude. That means BD is on the same latitude. Okay, you know what's latitude? Latitude is the line that goes from left to right on the Earth. It's not the great circle. It's a smaller circle compared to the great circle. Great circle is the biggest circle of our Earth. So look at this. Normally, when I label this, okay, I will label the 99 west on the left-hand side of the circle. Now, after we have drawn a big circle, try to draw a bigger circle as you can, at least maybe pick up 1/3 of your paper, okay? And after that, you draw the straight line in between the circle so that we know that this is the center of the circle and this is the North Pole, South Pole. So we need this line so that we can draw our equator. Okay, so we draw our equator and make this circle look 3D now, like a sphere. All right, so this is 0 degree. Now, we need to mark down 15 south and 99 west. So instead of marking our A in between here, normally we will use the side of the circle. Okay, that means I will take this line as my 99 degree west. And therefore, the opposite line, which is 180 degree apart, will be, now always take 180 minus 99. And if this is west, this must be east. This is actually a formula. The relationship between the two longitude, yeah? It's like this. All right, so over here we have 81 degree east. And therefore, 15 south must be below our equator. So let's just draw the latitude here and mark it down at the side, 15 degrees south. And this one will be our A. So let's use this one, mark down. This is A. Okay, B is Y degree north and 99 degree west. That means it's on the same longitude, but it's above this equator. So let's draw it over here. Okay, so our B, okay, normally I will make it 3D like this. I'll make it 3D effect. Okay, so this is the diameter of the latitude. Oops. Okay, this is the diameter of our latitude. All right, so this is, we have done, and therefore let this point to be B. Okay, B is Y degree north, 99 degree west. Done. Huh? So C and D, where are they? I have no idea yet, but it says that BD is the diameter of the common parallel latitude. That means for this parallel, this latitude, D is on the other end. So D is here. So let's mark down D. So now we need to find the longitude of D, isn't it? D is located here. D is located on this side, which we have just found the longitude on this side, all right, is 81 degree east. So we have found A right away, okay? 81 degree east. So this is a formula, okay? When one end is theta degree east, the other end will be 180, always like this, huh? The other end will be 180 minus theta degree west. This side is east, the other side is west. Vice versa. If this side is east, the other side will be west. And normally we put east on the right side, west on the left-hand side. Okay, so how to get the answer to A? The concept used is this. All right, let's move on to part B. B lies 4,800 nautical miles due north A. You see B is here, is north. That means it's along the same longitude, yeah? So in that case, we just use the formula. What formula is that? Okay, to find the distance on the great circle. So the concept, distance on great circle. Great circle is the meridian that has the center of the earth as the as its center of the circle. So distance on great circle is take the angle between the 2 points times 60 in nautical miles, the units. So in this case, we want to find the distance AB. It's given 4,800. So where's A and where is B? Okay, so it's over here, A is here, B is here. And when we measure the angle between them, always draw them towards the center of the circle. All right, so let's use this one. Okay. All right, and then from this line, okay, the straight line, the diameter of the earth, okay, we will have this angle 15 because A is on the latitude 15 degrees south and B we don't know yet, so let's call it alpha here. All right, now so AB, we want to find the distance using this formula, theta times 60. So theta times 60 equals to 4,800. Therefore, theta, the angle between A and B, will be 4,800 divided by 60. So we have 80 degree. Therefore, alpha will be 80 because the angle is from here to here. Alpha plus 15 is 80. Therefore, alpha will be 80 minus 15 degree, okay, which give us 65 degree. So we have found the latitude of B, which is the latitude of B is 65 degree north. Okay, we have to mention whether it is north or south. Okay, without the north, then your answer is incomplete. So that is part B. Now part C. Calculate the shortest distance. The shortest distance in nautical miles from B to D. So B is here, D is here. That is measured along the surface of the Earth. Now, actually, the shortest distance, okay, this is another concept that you need to know. The shortest distance can be obtained when the object travel around the great circle. Travel around the great circle. So in this case, instead of moving along the latitude, okay, B to D, we move along the great circle. That means it will go through the North Pole. Okay, so let me use the highlighter to highlight the path. Okay, so we move from B to D through the north. So in that case, we need to take the angle, okay, from B to N to D. Okay, how do we find the angle between B and D? So remember that this is the diameter of the circle. So it's 180 there. And we also know that the angle here, because this one is 65 degree north, that means from the equator, this is 65. and the other side also 65 because they are on the same latitude. So the angle in between them, so let me put it here, part C. All right, so the angle between B and D, so let's put angle BOD equals to 180 minus twice of 65. Twice of 65. So we have 130 here, so 50 degree. Okay, we have 50 degree here. And therefore, the shortest distance, B and D, will be using this formula, yeah, along the great circle, 50 times 60, the unit is in nautical miles, so 3,000 nautical miles will be the shortest distance for our C. Okay, 3,000 nautical miles. Okay, now the last part of the question, now part D. An aeroplane took off from C. Now, where is C? It's not on our diagram, but it say the aeroplane took off from C and flew due west to B. Due west means it towards west, yeah? Towards west and B. That means C must be along this latitude. Okay, but where is that point of C? I will just create another longitude that stretch from the North Pole to the South Pole and mark down my C over here. Okay, so the aeroplane will fly due west, okay, and then flew due to the south to A, like this. So we'll fly like this, and then like this, C to B, and then to A. Okay, and then it says that the total time taken for the whole flight was 20 hours and 30 minutes. That means over here, we will have the time 2.5 hours. Okay, let's change to hours, yeah. Okay, a little bit here, so that we have more space. Okay, so part D, we have the time 20.5 hour. And then it says that, what else? Okay, calculate the distance in nautical miles from C to B. So we need to find from C to B, okay, the distance along the latitude. So the distance along the latitude, if distance along the great circle is theta times 60 nautical miles, the other formula, distance along the latitude, okay, the formula will be theta times 60. We need to multiply the factor cos of the x. This one is due to the latitude. Okay, that is the latitude. Okay, so in this case, because C is on the latitude 65, so the x will be 65. Okay, remember this formula. So basically, for distance, we have two formula. One is theta times 60 nautical miles, that is along the great circle. But if it is along the latitude, then we will have a factor that make it smaller, that is cos of the latitude. Okay, so you can think this way. The distance along the latitude, okay, is always smaller. So theta times 60 because of the latitude value. Okay, you can memorize like this. Now, so let's move on to solve the part 1, D part 1. Calculate the distance C to B if BC is 2/3 of BD. Okay, so part 1, let's say BC is 2/3 of BD. So since B to D is a diameter of the latitude, therefore the angle between them is 180 degrees. So we will have this 2/3 times 180, yeah? 180 theta times 60. Okay, that's the formula cos 65. That is the value of x. Okay, use the calculator and calculate the distance between B and C. We we got the answer 3042.85 nautical miles. Okay, so we have just found the answer for part 1. And part 2, calculate the average speed. When you have average speed and then the time, it's actually, you know, the concept of dolly the sheep. Use this formula: distance, time, and speed. Just that the units is different from our common unit like kilometer per hour, and so on and so forth. Over here, we just use nautical miles and knots. And since we have the T, and we need to find the average speed, so the average speed will be S, yeah? So cover the S. We have to take the distance over the time. So average speed equals to the total distance over the total time. So the total distance will be from C to B, which we found in D part 1, plus A to B, which is given in B. So the total distance will be 4,800 plus 3,042.85 nautical miles over the total time, 20.5 hours. Overall, the speed units must be in knots. Okay, so just take the calculator and calculate the division of these two values. We have 382.58 knots. Okay, so that is how we solve the Earth as a sphere. I have few more videos on Earth as sphere, so please please watch each video, and you will notice that I always draw the circle and the steps to make it 3D, and then how I put in the information on the sphere that we have just drawn. And the important formula will be in this chapter will be this one: theta times 60 nautical miles, that is on great circle. Okay, the great circle will be the circle that take center of the Earth as the center. That is great circle. And we have distance along the latitude. That is the formula over here. Theta times 60 cos of x. The x is the latitude value. Okay, it's not the great circle, it's definitely smaller. It's smaller because of the value along the North Pole or the South Pole, towards the north or towards the south. So that is 60 cos x. Okay, and the last formula will be to find the distance involving the time, involving the speed. So we go back to dolly the ship. Now, what is dolly the ship? D is actually distance, T is actually the time, and S is the speed. Okay, so we use dolly the ship to help us to remember. Okay, dolly the ship is actually the first clone ship in the world. Okay, I don't want to go deep in that. All right, just use this one, dolly the ship, to help us to memorize the formula when we want to find either distance, time, or speed. Okay, if you want to find distance, cover up the D, you will see T and S side by side. That means T times S. If you want to find T, cover the T, you'll find that D over S. So that means D divided by S. If you want to find speed, just take D over T. Okay, and also another formula that is the one that involves the longitude on these two ends, the both ends. Altogether, the value is 180. So if one of them is theta, the other one will be 180 minus theta. Okay, theta, the other one will be 180 minus theta. And then their one is east, another one must be west. Okay, so that's it for this Earth as sphere. Should you have any question, just leave your question in the comment area. I try to come back to you as soon as possible. Thank you very much.